5 review is a big one on, today we're just going to cover quadratics in chapter 5A for the review. On Thursday, we'll do the imaginary part. Well, I gotta talk so people can listen here. Hi. Okay, so one of the biggest things that you guys learned was the quadratic formula, right? And that is used when you guys have a quadratic, meaning something's in the form like ax squared plus bx plus c equals 0. And it's a way that you guys can always find x. Okay. And you get your a, b, and c values by the numbers and the sign that are in front of each of them. So here your a is 3, the b is a negative 10, and our c should be 5. This is a great way to find x if you guys don't feel like factoring. You can always use this. So we set this up. Watch out for this. Negative 10 in your formula's got a negative, so what does that become? Positive. Good, little positive. So positive 10 plus or minus the square root. And this part underneath your radical, you got to be careful of. B squared, you have a negative 10 squared. So just make sure that in parentheses, otherwise your operations is messed up. So minus 4 times 3 times 5, all over 2 times 3. Okay. So reduce what you can, this becomes a 6. Now underneath the radical, we want to do just this part in your calculator. Watch out for those parentheses. Yeah. Okay, great. Okay, so then you can have, yeah, good, 10 plus or minus, oh, actually, before we do the work thing, you have to reduce the radical, Andrew. Good, reduce that radical, yeah, you want to make sure simplest form. Okay. So, simplest form, you're going to reduce your radical. What is 4 and 10? Good job. Thank you. It was 4 and 10? Yeah. Good job. And that becomes a 2. We should have 10 plus or minus 2 radicals, 10 over 6, and make sure when you guys reduce it, room for our little heart. And then we'll go through all 3 of them. 2, good. So 2 goes into 2, 1. This becomes a 5, and this one's a 3. Yep, so it should be 5 plus or minus radical 10 over 3.
Did you do 5 plus or minus 3, 5 minus 1?
Yeah, you can split it up if you want to. Yep, that's totally fine. If they ask you guys like nearest like decimal, like let's say find x to the nearest like 10 or something like 100. Do you guys remember the enter this in? Like you have to do 5 plus radical 10 and then divided by 3. Okay. So like 1 year would be like 2.7.
Someone showed you 5.
Yeah, then you would do the negative. I don't know if it would be negative 2.7.
Yeah. So if you wanted to like factor in?
If you wanted to like, if they didn't say leave it in simplest radical form, they said like find x to the nearest 10, you'd actually have to like do it out.
And you get 2 answers?
Yeah.
Would they ask that?
They might.
Or would they not?
Fair game. Alright, discriminant, you guys will see at least one discriminant question on your Regents exam. It's a really big topic. Usually, it is in the form of like example 2. What the discriminant is it describes the roots, right? It tells us about what the roots or what the values of x are in the quadratic. It doesn't tell you the value of x, it tells you about like the number that x is. So the keywords for it are going to be anytime we see keywords like real, rational, equal, imaginary, those are all clues to use the discriminant. Okay, we're going to go through what each of these like your keywords kind of means as like a little bit of a reminder. So when you guys see that, when you see these describing words, we use our discriminant, which is e squared minus 4ac, just what's underneath your quadratic formula. And so take your a, b, and c values, from above.
For instance, equal, what does that mean?
Equal means your discriminant will be 0. Oh, like as the roots? So equal would mean if you did all your factoring, if you would have x equals 2 and x equals 2. Like your bubble would have been like, so when you set this here, you have x equals 2. Like your roots are the same. Like this, what Andrew discussed? Probably not, like clever. I'm not going to make you like give an example.
No, never mind, just go on.
No, it's okay. I think you can come back to that.
No, because I just already did it.
So now if you guys plug this in, what did you guys get for your discriminant? 81. You guys get 81? Everybody get 81? Good. So let's go through, because this number is going to be something that you guys want to look up here with, and it's going to describe some things. So when you have the keyword equal, right? Equal means that the discriminant would have been 0. Okay. When you have the imaginary, do you guys remember what your discriminant would be? Negative, good Lily. It would have been a negative number. Now the other two are where we need to decide things, right? They look exactly the same, except that one is rational and one is irrational. Irrational is a positive, non-perfect square.
It's 2.
Good.
0, rational.
Wow. Good job, and you are a perfect square. Good. So when it's a rational, it's a positive perfect square, which would make 81 is a positive perfect square, so we should have choice 2. That's good, just to like remember a lot of what those all mean, because you don't know what you're going to get on it. You're going to get positive perfect square, 0.
But then there was one where the roots would be equal to the
well, if you got 0 here when we did all this,
oh.
that would be, like it physically, the answer would be 0. Yeah. I usually see it come up like this, not with the graph, but this is from a Regents, it's like their game. So I just want to make sure that we remembered some things about what the graphs look like too. When you look at a graph, when you're talking about things involving the discriminant, it's how many times it crosses the x-axis. So in this, do we ever cross the x-axis? No. Do you guys remember which one it is that never crosses the x-axis? If the roots or something? Imaginary, you're right. Good. So things that are imaginary never cross the x-axis. Do you guys remember which one touches only one time? The 0, so which would mean equal roots. Good. So if you got a 0 discriminant, your roots would be equal, and this would touch only one time. I know we talked about the word like tangent. Yep. If they give you guys one, they only choose between 1 and 2. They're not going to put something where you decide between 3 and 4.
Yeah, how would you?
You have to actually like figure out probably what the quadratic is and what the roots would be, like physically decide what they are. And they're not going to make you do that. So these would be 2 times. Yes.
I don't think so. I'll stay in a project.
No. Can't. Alright, so this, I think, this would be, this comes up once in a while, like,
I noticed your shirt.
once,
Andrew, I don't need your attitude.
okay.
Sorry.
Okay, this one is a hard way it would come up, okay? So I'll take a second, look through it. Are real and equal if k equals something. Alright, so you got keywords here. Real and equal. Andrew, what do you think about those?
I chose just 2.
Oh, how'd you do it?
I plugged, so I did my discriminant.
Okay.
And then I just plugged in different things.
Oh, okay, so you did like guess and check.
Yeah.
Okay. So you took, let's see, -4 squared minus 4 times 2 times k, right?
Yeah.
And you just started plugging in all your multiple choice?
Yeah.
It would be so much easier because
Well, what happened when you put 2 in here? What did you get?
I got 0.
yeah, 2.
0, good. And what's your keyword up there? Equal. Yep.
Don't you have to just do first and last and then the sum? That's what I did. I did, well, because, okay, 2 times 2 is 4, and then the sign in the middle is a negative, and but the
Oh,
sign.
no, I did 1.
Shut up! The sign at the end is positive, so it has to be the same.
Oh, you like, okay, you could have done that, I guess. You could have done that. Four. Oh my gosh, wait, it's not this. Look at that hand.
Oh my god, this video is all messed up.
16 minus, this would give you guys 4, which times 4 is, hey, no, it's right. 4 times 2 is 4, right?
4 times 4 is, you're so stupid, don't talk.
I just put it into the calculator and it said -32.
Wait, did you put parentheses on them?
You did it.
This way. No,
Come on,
okay.
Andrew,
Alright,
that's
you were
the
right.
whole video.
Now listen though, we need to make sure that you guys do this if it's not multiple choice. Because I've seen this come up when it's not, when it's like a part 2.
Oh, you're gonna show work?
Yeah, you gotta show work. And you don't have these like options to plug in. So what you would want to do is kind of the same idea, right? If you know the key word equals, you know that the discriminant has to equal 0, right? So now, all we have to do is put in your -4 squared minus 4 times 2 times k. So this time is equal to 0. Yeah, so now you're literally just solving now. Exactly, so you're trying to get k. Okay, so for minus 16, -8k equals -16, divided by -8, so k has to be equal to,
Apparently it's not 2, according to Andrew.
oh, sorry.
I think you wrote the video.
Oh, hi. Really? You tell you?
Can I give them his address?
Alright, so this is one that comes up.
Ouch.
Right. Now the other one besides like equal to that comes up is if you have stuff that's imaginary. So if you guys had something that was imaginary and they said that, you don't have to actually do it, but to set it up. If you know you guys have roots that are imaginary, what do you know about the discriminant?
It'll be negative.
It'll be negative. And the way you represent that, what do you think? How can you represent something that's negative?
Putting a negative sign in front of it.
Oh, no, I. Alright, well,
What are you even talking about?
okay, well, if it's equal to 0, you write equals 0, right?
Yeah.
How can you represent something negative? Is it greater than 0 or less than 0?
Less than 0. So what are you trying to get at?
Just this part.
Yeah, why?
So if you want,
Well, because it's just another way that they might write this.
What is less than
but if
0?
they give you an imaginary number, you have to write it like that, and
Yeah.
solve it like that,
Yeah.
and be like, oh,
Exactly, I.
okay.
Exactly.
It's like equal.
Frida, this is for just this example.
Don't say my name, you said other people.
Alright, this is another big thing. Some part of the roots is going to come up somewhere in here, so the formula, you guys want to make sure you know that the sum is negative b over a, and the product is c over a. Yep. Okay, so with the sum and product of the roots, you get your a, and b, and c from the same exact spot. Just make sure you're careful when you guys are using your formula here. So a is 2, b is -4, c is 1. So if you want to find the sum, we're using our formula. So make sure you watch your negative sign. Negative is a positive. Good job. 4 over 2, which is really just 2. There we go. And then your product is c over a, which is just 1 over 2 and 1/2. So it should be choice 2. Do you guys remember those? Okay.
I don't know what it was, it's something about, like, so you can remember it like sad and black, and it has nothing to do with it.
You just remember it that way? That works?
I don't know.
What happened?
Someone said, hey, you can make words out of that, like sad and pack.
I'm pretty sure that was me.
It didn't make any
I
sense,
think so,
but
yeah.
it worked.
Okay. All right. So here's the
when
last
I'm
one.
in my Regents and you fail, well,
Okay, no one's gonna fail.
except for Andrew.
All right.
She's just being nice.
Completing the square, you guys will see somewhere in this. And we did this in the last review class with circles, if anybody came. So it's very similar to that, except we don't have like x's and y's mixed in, right? So completing the square, right, what we're going to do is always make sure your leading coefficient is 1. So look up here, is your leading coefficient 1? Right. And they'll tell you guys when they want you to use completing the square, they have to tell you. Because otherwise you could just solve by using factoring or quadratic formula. So they have to tell you to do it. Right? So our first step is to make sure the leading coefficient is 1. Alright, this one looks good. Next one is to move all constants to the other side of the equal sign. So how do we move this plus 6 over? Great. Super. Then we do the bubble thing, right? Alright, whatever letter you're dealing with, you put that in there, make it squared, got our minus 6 there. What do you want to do with this middle term?
Take half.
Great, take half.
And then don't you square that half to the other side?
Yep, perfect for you. So negative 2 squared is going to be 4, because we're going to have to add 4 over. Equals negative what? 2, perfect. Now, close. Now, usually what they see in this is they'll say, like, what's an intermediate step in completing the square? So this will be like just what they're looking for. If they say solve for x by completing the square, we have to keep going. How do you guys get rid of something squared?
Take a right.
Square root, good job. Right, watch out in here. We have to put in front an I, plus or minus. Good. Okay. Okay, so those are going to cancel. So we get x minus 2 equals plus or minus radical negative 2. Right, well, we want x to be alone, so how do you guys move that negative 2? Yeah, right, good job. Alright, so we got a lot of stuff to do in this. Okay, is 2 and a plus negative a radical? Or like radical, are those like terms? Okay, we got one extra thing we got to do.
You have to put an I.
Oh, good job, Linda. Why do we need an I?
Because you have a negative in the radical.
Good. All right. So we're going to take this out and we make it an I. Right. No negative under the radical. Okay. So when you guys finish this, it's going to be 2 plus or minus I radical 2. This is going to be our answer.
Can you pop the concept for it?
Not really. Mm-hmm.
Nothing with it.
You want to know
me?
You want to know.
Okay.
So now, this is a little bit tougher. Right. If you have a leading coefficient of 1, okay. Because divide by 4 makes sense. And make sure you guys do everything by 4. Alright, so if you guys divide the first one by 4, good job. Perfect. Okay, so now, this is looking pretty good. We've got a leading coefficient of 1. And the next step was to move our constant to the other side. Yeah, it's already moved, so this is even looking even better. Good job. Okay, so let's make our bubble then.
Maybe x plus 1.
Good job, Frida. Yep, because there's a 1 here, so if we take half of 1 is really just 1/2. Well, when you guys square 1/2, 1/2 times 1/2 is going to be what? 1/4. Or, in a calculator,
0.25.
Good.
Yeah.
Which is 0.25. Use your math action key is 1/4. Okay. So 1/4 is going to have to be added to this other side.
Not just 1.
Yep. So there's like 4/4, which is just 1. Good. Okay. Nice. So then we're back to the same thing. To get x by itself, we need to take the square root and get rid of this square. Make sure you put your plus and minus. So we get x plus 1/2 equals plus or minus radical 1. And then you want to move that 1/2 over by subtraction. really close. One more thing you can do here. What you guys do with the square root of 1? It's just 1. It's like a perfect square. Yep. And this is going to be 1 though. You guys are going to get 2 roots. Right? We can actually solve this more. We need to do, let's do negative 1 plus 1. Sorry, negative 1/2 plus 1. Then negative 1/2 minus 1. We need to figure out what this is going to be. Yep. So, it's like radical 4 is just 2.
Oh.
You need 1's a perfect square because 1 times 1 is 1. So now you take negative 1/2 plus 1. You're not sure? Is it calculator? And we get 0.5. And then we have to do negative 1/2 minus 1. And get negative 1.5. If they're given to you guys in fraction form, it's like multiple choice. You know, you can just change it. Yeah, negative 3/2. Right, so we should have, so it's going to be 1/2 and negative 3/2. The biggest stuff in here is like make sure you guys know discriminate, make sure you know completing the square, and make sure you know how to use your quadratic formula. Right, and subproduct. This is like a big stuff on your Regents.
So someone